C++ STL containers std list. Std list, like std vector, is a templated class which manages an array in dynamic memory space. Unlike in std vector, the container elements are stored in non-contiguous memory space. In std vector, the elements are always stored in contiguous memory space, which is the region for efficient random access in the case of std vector. Understandably, access of elements in list is less efficient than the element access in std vector. However, unlike in vectors, the data is not needed to be copied again and again as a new data is added into the list. I will demonstrate this in one of the programming examples that I'm going to discuss. Copy and move operations are allowed, like in the case of other containers such as std vector. In other words, you copy construct, copy assign, move construct, move assign the objects of std list. Let me explain it directly through coding. This is the basic skeleton code I'm going to use. I will expand it to explain it. So if I want to create an object of std list, first list, this is a template class, so I need to specify the type for which I want to instantiate it for. Let me instantiate it for integer type. Since this to use this container, I need to include the library list, and this container is defined in the namespace called std, so that's why you call std list. And now the name of the container, we can use any name, let's say my list. Right now, this line, this statement will actually tell the compiler to instantiate std list for integer type to create a class, and to use that class to create an object called my list by invoking default constructor. So it will create a list, but it's going to be an empty list, right? This class also brings the functions called size. We don't have capacity function in this case because capacity doesn't make sense in the case of list, unlike in the case of vector. In std vector, there is another function, capacity. Here we have size. So if I want to display size, I want to call this function through the object, right? So and then insert it into the output stream, and in a single line. So this will display the size, and there is another function called empty. To test whether the list is empty or not. If I want to display boolean output true or false, then I can specify to bool alpha, and it's going to be empty. So these two lines will display the size of my list and will display whether it is empty or not. Let me explain it quickly. Compile it, run it. This is the file main1.exe, main1.cpp I'm using, and it is going to be written in main1.cpp. I think there was a small typo problem, empty. Coming back to the terminal. So now this is the size is 0, the empty is true. That means when it was initially created by invoking a default constructor, it was a list object but it was empty. So it had a size 0 and it was empty. I can add I can also create the list object by invoking custom constructor 10. It will create a list with 10 elements all set to 0. So if I want to display the size and whether it's empty or not for my list, let me have the name different, my list 1. In this case, I should be able to see the size non-zero and empty false. So now you can see the size is 10, empty false. And if I want to see the content of the list, then maybe I can have a function called print. Let me create a templated function to receive any type. Container, and inside I can display size and empty information directly. So let me move this thing inside the function size, and maybe we can put empty together, and the content of the container through this range based for loop. If I have this thing constant, then I need to copy as a constant. C space and new line. So this will insert new line at the end of the display. Now with this I can call it directly instead of having these lines. Print my list and print my list 1. Right, so let me compile and see the output. There is a small issue. My list was not declared, so the issue was this the name, I should have changed the name to C and T here, because this is the name that is given for this name is local to the function. We cannot use the name that was defined in another function to this function. So compilation successful. Now you can see the empty 10 list of size 10 was created. It's not empty, false, and the content is 0. And similarly, you can also create a list by invoking different custom constructor to 10 elements, but you want to set instead of 0 you want to set the elements to, let's say, some value 55. So this is also custom constructor. Now if I display, then I'll not have 0 values for the in the list elements. So now we have all the values of the list element is 50, 55. So this is the way you can create a list, and also you can push the element, insert the element into the list by calling this function. This function receives an argument which is of the type for which the list is instantiated. In this case, it's going to be integer type. So 60, I am pushing 60. 65, 70. So I have pushed 3 items into this empty list, and if I print it, and let me show you what change I made. So I actually used the empty list, my list, and I invoked the function pushback and passed the argument value 60 into it, then 65 and 70. This is the function to add the data into the list. So this invocation will actually call this function and display this data. With that change, let me clear the screen. So now you can see 3 elements that were pushed into the first list that was created. Size now became 3, empty is false, and contents 60, 65, 70. And instead of pushing back, you can also push to the front. If I want to push let's say 33 to the front, so it will be pushed into a different on the opposite end of the list. So push back will push on the back side of the list, and the push front will push the data into the on the front side of the list. Right, so this is the way you want to write push front. You use the same object and call the function push front and pass the data you want to push into it, and then this function should display it. Compilation and execution. So now previously the list contained 69, 60, 65, 70 because the first 60 was pushed, and then 65 was pushed on the back and 70 was pushed on the back. If you push back, it will continue getting pushed in this direction, but if you execute the push front, then it actually pushed on the front side. So 33 actually got pushed on the front side of it. So this is the basics of the list, the uses. A few things to repeat again is the use of function size, the use of function empty, and you can use a range based for loop to iterate for its elements, and push back and push front, right? So this is this code actually explains the basic uses of the list. Now the subscripting operator or an add function are not available, which is available in vector but it's not available in list. For example, if I want to access element using this or at, so this is not available in list. Let me see what happens when I compile it. So it's already complaining at the point where this subscripting operator and add function is actually used. So we cannot use this function. So if I want to actually access element in the list, for example, only one element, second or third element, in that case I need to use some concept of a iterator, right? So what I can do here is maybe I can create a new list, by copying from this. So by the way, this list also supports copy constructor. So and then if I want to access, because I actually did this copying because I actually don't want to make changes to my list, therefore if I want to access the third element, then no, I think I can. I don't need to do this. Let me postpone this copy construction discussion for a moment. I will come to this in after I finish it. So there is a function that comes with the list, which is called begin. So I will discuss in detail about what it returns in another video, which explains actually iterators. So this actually begin returns an iterator pointing to the first element, and if I want to display the first element, I could just dereference it, because you can consider whatever it returns as a pointer to that particular element. So you dereference it and display it. And if I want to display the second element, I would increment iterator and dereference it and display. If I want to display third element, and increment one more time. So this way you can you need to have an iterator. I mean, you can change the element it is pointing to by adding the number into it, integer number to it, or by incrementing, and you can dereference it to display the data at that point, right? Let me see the output of this changed code. So now, in the first case it was 30, first element was displayed, in the second case 60 and 65. So I mean, this is the way you can access only one particular element in the list. So now the one key thing, the difference between a vector and a list is that whenever we insert a new thing into it, for example, dynamic memory space is allocated for this data 60, 33, and then dynamic memory space is allocated for 60, 65, but they are not contiguous, they are dispersed in the dynamic memory space. So when we add a new element, a new space is created, but there is no change in the previously allocated memory. This is not the case in std vector, right? So I actually would like to demonstrate that. To demonstrate that the address where this data are stored actually does not get changed when you actually make changes to either add element at the front, add element in the end, or add element somewhere in the middle of the list. For that, let me create a function to print the memory address where the data is actually stored. The name of the function I'm going to give here is print addresses of the members of the list, pass it as a constant, and int as a reference, and let me call this list, and here I want to actually I equals to I not equals to, it should be lst int and I plus plus. To be I mean, let me use it instead of I, because this is essentially an iterator, so I think it makes more sense to use it to represent iterator. And I want to actually display, so you can use you can access, if I put this expression here, it will actually display the data, but actually I want to display the address, not data. So ampersand operator, then after that new line character, insert new line, right? So this will actually display the address of the elements of the list. So let me display the addresses where this list elements are stored. Print so I think I missed it. Let me explain it a little bit, because I missed to switch the screen. What I actually did here in this period was I want to print an address of the elements. So for that purpose, I actually created this function, and the function is to receive the list object as a reference and a constant type. In the loop, if you use call the function begin with the list object, it will return the iterator pointing to the first element. If you call the end function with the list object, it will return iterator pointing to the last function. Essentially, you can think iterator as a kind of pointer pointing to those elements. So if you increase the iterator, it will actually point to the next element of that container. And if I have asterisk I, then I'm dereferencing this iterator. That means I'm accessing the data stored in that memory location. But if I want to display the address, then I will have to put ampersand. So this will actually display the address where that particular element is stored. In this case, if I iterate in this loop, that means the elements of all the address of all the elements of the list would be displayed separated by comma. So now if I call that function and pass my list, I would expect the addresses to be displayed. Let me see. Oh, I think after I made a change, I changed the I to IT, then I actually missed to change this to IT. So back to the terminal. So now I can see this is the address displayed, 3A810, 3A7B0, 3A7D0, 3A7F0. It's not necessary they will, maybe the address are consecutive, they can be spread in different places, but the main point I want to see is, for example, in this container, if I add a new element, then the previous addresses are not changed, or addresses of the previous elements are not changed. So if I, let's say, push back a new element, 99, after that I would have actually have a statement to print the addresses. I think there was a spelling problem in the code. So now in the previous case the previous elements are after the change, the new element was inserted. The previous elements have the same space 810, same memory space, memory location, and the new added element actually got this new address. And you can also insert an element in the between. For example, if I want to insert the number, let's say 120, in the third position, right? So if I have this is the element first, second, third, fourth, fifth. This is the address of the elements. So if I want to insert a new element in this place, in between these two items, then I can use the function called insert. I can call my list dot insert, and I need to specify that address. So the way I specify is going to I'll have to use that iterator. So like in this case, if I use this, then it will actually insert in the third position, right? So if I pass this iterator, it will insert in the first position. If I pass this expression, actually it will insert in the second position, and it will insert in the third position, right? So first you specify the position, and then the data you want to insert 120. I actually want to insert 120 in the third position. So let us see whether we can see the changes difference. So now we can see in the previous case it was the elements were stored in 3, 810, 70, 70. Now the new address is appeared in this place because the new element was inserted, which got a different memory space, and these addresses were actually moved afterwards. And you can also display the data at this point by calling this print function. Right, and similarly you can also remove that element after that. My list, let me have a print statement before inserting. Switching the window. So what I did is I actually inserted this print statement so that I also can display the data in addition to the address by this function invocation. And before that, before insertion, I also want to display the data. And after that, I actually want to remove that particular element. For removing, I can call the function erase, and I specify this position. I don't need to pass the data because I'm actually removing the data from there. So there is no need to pass the data. So after erasing, first it will have the list with elements 60, 65, 70, and then push front and push back, 99 pushed back, and then afterwards it will attempt to insert the element in the third position, and then it will erase, display the data and erase the element, and then again display the data. So let me see this output. there was something missing. Let me go back to the code and fix it. So now you can see, let me clear and run again. So you can see in the beginning the data was 33, 60, 65, 70, 99, and after insertion 120 came in here. After erasing or removal, it went out. And the address, the new data was stored in this address, so it came in between these two addresses, and it was actually in this place, it was removed. The address appears removed. Therefore, if you insert the data in, if you insert data into the list, it will allocate memory, and that memory for that particular element will not be changed. It will remain the same unless you actually remove that element from the list. So this actually explains how to insert data into the list, how to erase the data into the list. And let me also explain the copy construction and copy assignment. So for that, let me clean this a little bit, remove this thing, and I want to have this list populated with some data. And I want to actually apply the copy construction and copy assignment, move construction, move assignment to this. So I actually don't need this print address at this point. Now I will now want to need this display the data. So I can copy construct my list new object. I can create this object by copying from the existing object. So once I copy construct, or maybe let me have another list, my list 3, so I can also copy assign equals to. So I have 3 list object. The second was created by copy constructing from the previous list object, and the empty, this is empty list object, and then it is copy assigned. My list 2 of data is copy assigned to my list 3. And now let me print. First, second, and third object. Was not declared. I think the issue is what it should be. Yeah, I should have used my list 2 instead of 1. So compilation, and now you can see in the beginning it was empty, then it was populated with data. 30, 60, 65, 70 was back inserted, and 33 was front and pushed from the front side. And this was the data in the object created through copy construction, and this was the data in the object copy assigned. Now let me also demonstrate the move operation. You can also move the data. For example, let me create my list 4. I want to move construct from my list, and my list 5 for move assignment, and 5, let's say 2. So 4 objects are involved here: my list 2, my list 5, and my list 4. So let me display the data. I would like to display this data, and obviously my list has the data into it, and my list 2 also has data into it. It was displayed in the previous execution. Let me print my list first, print my list 4, print 2, 5. So the expectation here is that my list has to be moved to my list 4. So this should display empty thing, right? So I think I also want to have yeah, if it is empty, it will this will actually have the information we can see. The size should be 0. So this my list should have been empty once it is moved into my list 4, and my list 2 should also have been empty once it is moved to the my list 5. So let me see the output here. So the last one, in this case, this thing, we should start from here. So this was my list, and it is copied to my list 4. So my list became empty once it is move constructed, and then it was my list 2, and it was moved to my list 5, I guess. So this was the move operation. Once we have move operation, the resource data is actually moved to the new thing. It's not unlike in copy operation. In copy, you create a copy of the new object by copying the data, but the data in the source object remains intact. But in the case of move, the data in the source object does not belong to it anymore. It actually belongs to the object into which it is moved to. So now this is all I wanted to discuss here. C++ STL containers, std list. This is the end. Thank you for watching.